Many thanks to pcbway for sponsoring this video.
Good day everyone, I'm Yankee Oscar 6 Delta X-Ray Echo. Welcome back to the X Explorer for another video. Today I'm back with the rain, which doesn't seem to stop and it's very annoying, but there's not much I can do and we have to deal with whatever we get. But I'm also back with an older project. Some while ago, a couple of videos back, I presented to you the RF tap slash RF sampler, and I was really happy about the results that I got with that one, and the fact that I was able to finally measure harmonic suppression when it comes to building transmitters and transceivers, especially for HF, which is my main interest, if I could say. And I decided to build the final version, but it's a modified version, and you'll see in a little bit the way I decided to build this one. It's a little bit different compared to whatever you might find online, not because I didn't like those, just because I had to find solutions to my technical problems, and this is what I came up with. But I really like it, it performs really nice, and I hope you like it as well. It's a really useful thing to have, especially when you're into building HF radio equipment like transmitters and transceivers. And yeah, not sure about the power that this one can handle. I built this one rushing to finish it just because I wanted to be able to test the RF amplifier that I built for my friend Vlad. And I hope it can handle at least 50 watts, but it should, because I actually used the dummy load, which is incorporated into this one, for 20 watts and just a little bit over 20 watts with no how do you call it, no heatsink, and it only heated up a little bit, so it was not such a big deal. So I'm pretty sure it can handle 50 watts, especially if I only do like short bursts of transmitting into the dummy load that it's incorporated into this one. So anyway, useful tool. Let's have a closer look. I hope you like it, and I hope you'll find it useful. And yeah, but of course I'm not going to continue without saying thank you to my friends at pcbway for always sponsoring and supporting the DX Explorer channel. They have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more services available for you. If you don't have an account for pcbway, have a look down in the video description. You'll find a link and you can use it to register for your new account, and you'll get a discount on your first order. Again, today I would like to talk to you about the PCB assembly services, because I have a lot of YouTube subscribers which they seem to be very happy about this particular service. Some of them, they just are not so good with the soldering iron, and the others, they just don't feel like heating it up and start soldering parts and components on the PCB board, probably because they don't have the time. So if you're one of these, you always have the option to order the assembled version of any of the projects that I'm presenting here on the YouTube channel and over there on the pcbway project files. And yeah, if you feel like ordering PCB boards, you can always have the option to order the assembled version. So I hope you like it, and I hope you'll enjoy it just like the others. As I'm always saying, PCBway is the way.
Okay, here we are. So we have the RF tap slash dummy load finished. Here's the input, and here's the output that goes to the tiny SA. This is the input that comes from the transmitter or the transceiver, and I placed here on top of the enclosure, I could say that it's a tiny heatsink. Unfortunately, I didn't have anything bigger. Initially, my idea was to build the whole thing into, you can find this online. I think it's a 5.5 centimeters by 5.5 centimeters. It's like a square shape cast aluminum box with like a top cover that you can screw in from the top. And I believe it's Hammond, the manufacturer, but I'm not sure. I can't tell exactly. But those I really liked. Unfortunately, honestly, for me, with the postal services and everything, it's quite expensive. And The good part for that was that I could also find a really big and serious heatsink that will fit perfectly in that square shape. But yeah, that one was also too expensive, so I built with whatever I found available. The good part with that, and if you can afford that, I would really recommend you to build it that way. It's a lot easier because you can place the heatsink on the back of the box, and you can work very easily from the other side where we have the cover, and once you finish everything, you just screw it, and the cover will be the bottom of the box, and you can just place some little legs like I did over here, some rubber if you want, or whatever you can find available, to use it as a, to stand on the desk. It will not scratch the desk. But yeah, I built with whatever I found available. I can't remember who gifted me this enclosure. It's either my friend Vlad, Yankee Oscar 5 Bravo Delta Lima, or from my friend Andre, Yankee Oscar 6 Tango Juliet Juliet, one of these two. They gifted me the box and the enclosure, and I decided to use it. And the heatsink, I have it from an old computer. I can't remember on what it was used, but that is what I had. Anyway, let me open the box really quick. I'll show you the way I built everything inside and explain a little bit more. Okay, so this is the interior of the entire construction. So over here is the two screws that are holding the dummy load. So the trick that I made was to install the dummy load inside the enclosure. It's the same dummy load that I'm using for the RF watt meter that I also presented in another video. So what I'm doing now is that I'm using the RF watt meter with an external dummy load. So I will put the RF watt meter in another enclosure, its own enclosure, and that one will have an output for the 50 ohms dummy load, so it will come over here if I want to do any power measurements. And my idea initially was to place the dummy load in such way that the connection between the BNC connector or whatever connector you want to use it will be as short as possible. Unfortunately, I had to deal with whatever I found available, so this is the way I soldered everything. I measured everything. It still has 50 ohms, and it's fine, so there's not such a big issue. To make sure that I have a proper connection, since the box is actually painted, I soldered a wire between the ground of the BNC connector to the ground of the dummy load, and this way I make sure that I have a good connection between both of them. But anyway, I realized that even without that one, there was still a good ground between all the connectors, including the output to that goes to the tiny SA. But I also had here a copper wire that I could solder to the dummy load as well, or to the connector, this connector over here, to make sure that I have a good ground. But since I already have a good ground, I didn't solder that wire. Now on the output that goes to the RF, to the tiny SA, I respected the same thing that I had in the RF tab that I built originally. And if you look on the screen, you will see the schematic. There is basically oh my god, I just realized that I'm saying basically too many times in my video. I have to stop this bad habit. Let me know when I say something too often, because I just watched the video that I posted recently, and basically I was saying basically all the time, and it became very annoying to me. So anyway, we have this 100 nanofarads capacitor. The signal that comes through the resistors, the attenuated signal, goes first through the 100 nanofarads capacitors, and then it goes to the BNC connector, to the center pin of the BNC connector. And if you look in the schematic, you'll see that there is a 50 ohms resistor that goes from the one end of the 100 nanofarads capacitor to ground. What I did here, I used, I think these are 2 watts or 1 watt, I can't remember, I think it's 2 watts resistors. They are 100 ohms each, so technically since I have both of them in parallel, they will become a 50 ohms resistor, just like in the schematic. And then these 3 resistors, these are also 2 watts resistors. These are 820 ohms each, same like these are actually the same resistors that I used in the original, the first RF tap that I built. And yeah, the only difference is that now I'm no longer using that brass shape that I found to be used in the original design, the one that I used as an example to build the first RF tap. But it seems to be fine. I'm still getting 50 ohms over here that goes to the dummy load, and I also get 50 ohms here on the output for the tiny SA. All the measurements, they seem to be fine, decent enough for HF, so I didn't bother doing anything else. This is the technical solution that I found, the easiest way for me to build this thing the way I wanted to build it, and if it works, it works. There's not much I can do. So that's it. It's just as simple as it is. Of course, again, I will comment that I might not be able to do lab grade measurements, but it's good enough for me. It's I have decent performance, and the part that I'm most interested in is to work well on HF. So this is it. Very simple. Let's put it back together and start doing some measurements with the NanoVNA to see the performance and how well it responds on different frequencies and how much attenuation we have. And I guess that's the whole video for today. I wanted to present to you this one because for me at least, it's a very, very useful tool. And if you don't have one, I would really recommend you to build one. If you don't have the budget to buy some really expensive RF attenuators. Okay, so I connected the NanoVNA, not the tiny SA, to the RF tap / dummy load, and port 1 goes into the input, which is going to the dummy load, to the resistor, and then the output, the one that's technically going to the tiny SA, goes into port 2. And these are the measurements that we get on the tiny SA. Let me zoom in a little bit. I'm trying to keep it in a way that it will not reflect the light. So let me see also what I'm doing here. I'm somewhere around 976 kilohertz. I'm getting about -42 dB of attenuation, and the resistance of the dummy load is somewhere around 47.2 ohms. Now let me go a little bit higher, somewhere around 1 megahertz. Oops, I went too high. Closer to 1 megahertz, 900 kilohertz. Okay, 1.2 megahertz. Over here also the resistance of the dummy load, of the output actually, not the dummy load, it's 47.23 ohms, and the attenuation is again -42 dB, -42.8, you know, around there. Now I will go somewhere around 14 megahertz, just out of the curiosity. Let's go around 15 megahertz, somewhere in the middle of the HF band. Over here again 47.9, nearly 48 ohms. The how do you call it, the impedance, and then minus 42 dB of attenuation again. Let's go all the way up to 30 megahertz, and over here we have 49.5 of the impedance, ohms, and again minus 42.6, minus 42.7 dB of attenuation. I think I'm measuring the right way, but that's what I've seen online. Remember that I'm also learning things. So sometimes to measure something, I'm also checking whatever other people that have more experience than I do. I'm checking whatever they measure and the way they do it, just so I can also test my own equipment. But yeah, so far it looks good. What I'm going to do now is to go, I'm not going to calibrate it because I'm not so interested in VHF and UHF. But I wanted to show you something anyway. Let me start with 140 megahertz and stop on 160 megahertz. Over here the attenuation level, it's a little bit lower. Here I only have minus 37 dB. The impedance is somewhere around 59.6 ohms on the output, and if I go all the way to 160 megahertz, the impedance is somewhere closer to 50 ohms, around 51.8 ohms, and the attenuation level is minus 36 dB. So it's not exactly minus 40, but I'm nearly there, so I think it's good enough. I'm able to do some proper measurements even like this. I believe that if I would go somewhere on the UHF band, the attenuation level will not be that great. But unfortunately I realized something on my tiny essay, and we'll talk about that a little bit later. Let's go to 430 megahertz and stop on 450, for example. And here it starts to act a little bit crazy. So on 430 megahertz I get minus 32 decibels of attenuation, but the impedance is 102.3 ohms. So here it starts to go a little bit crazy, and the reason for that might be maybe the resistors that I'm using, those two resistors in parallel that I have on the output. I don't know. It could be possible that it might be because of those. Maybe they don't react so good on these frequencies. And all the way to 450 megahertz, the impedance is 88 almost ohms, and the attenuation level is minus 31 dB. Could I still use it on UHF? Maybe. I don't know how accurate the measurements might be, but considering that I'm just measuring the harmonic suppression, I think it's good. I don't know. You guys leave me some comments if you have more experience than I do in this. But again, my interest is the HF band, so probably maybe the reason is that I also I didn't calibrate the NanoVNA for those frequencies. I just measure like this right now. It's possible that if I calibrate the NanoVNA for those frequencies, it might respond a little bit better. I don't know. I'm not going to bother because I'm not so interested in VHF and UHF. Mostly HF. But probably at some point I will do it out of curiosity. So let's go back to 1 megahertz, stop 30 megahertz, and I get something really nice, really flat line, and this is what I'm interested in. So it works well and I like it, and this allows me to do the measurements that I'd like to do. Alright, this is something off the record. It has nothing to do with this video, but I wanted to, since we're talking about tiny essays, I wanted to ask you guys, those who have more experience with tiny essay. I have an issue when it comes to frequencies. So I suspected for a while that maybe this is some sort of fake tiny essay, but it's not. I have everything on the back, serial number and everything else. There are a lot of methods online. You can find a bunch of YouTube videos that will help you to discover if you have a fake tiny essay or an original one. Maybe this is an older version, I have no idea, because I updated the firmware to the latest firmware from tiny essay. It works fine. It will pass all the tests and calibration and everything. Let me see if I can do it really quick. Config, self calibration, calibrate. Oh yeah, because I have to wait. I have to place the wire between the. I forgot. I'm concentrating a lot on whatever I'm doing over here. Okay, let's do it again. So self-test, no, not self-test. Okay, here we go. Anyway, we're supposed to do this too anyway at the end. So it passed all the tests. I will go do a config, calibrate completed. So yeah, I don't know why it does that thing. I mean, the problem is that my frequencies are not exactly, you know, if you take a look on the back, it will say it works from 100 kilohertz up to 350 megahertz, and then from 240 megahertz up to 960 megahertz. But if I go over here and I go back, frequency, let's say 250 megahertz, the lowest, and the highest one I will say 600 megahertz. It should work, right? But it doesn't. So the highest frequency that will go is 350 megahertz, and if I go lower, it is on 250 megahertz, whatever I set in the settings, but it doesn't go higher than 350 megahertz. And I wanted to ask those of you who have more experience, if you had these issues, or if you had any tiny essays that have this issue, and if you found any solution to fix it and get it to work higher than 350 megahertz, because I have no idea how to do it, and I have no clue why it doesn't work, even though it does seem like a legit tiny essay. It doesn't seem to be a fake one, since it works with the updated firmware from tiny essay, and even on the back it says whatever these frequencies that we have, but still it doesn't work. So this is more like a scream for help from me to you, in case you know the answer to this issue. And thank you so much. If you do that, let me know down in the comments, and I very much appreciate the help. Okay, that's it with today's video. Thanks so much for watching. I think it's a good tool to have. Just one thing, make sure you use that white paste between the heatsink and the case to have a good heat transfer between these two, and also use the same white paste between the transistor and the case, so this way all the heat will dissipate very well into the heatsink and also into the case, because since we use a metallic case, this one will also use as a heatsink on its own. So anyway, I hope it's useful. I hope it helps you. It works great, at least on HF. It doesn't perform so well on VHF and UHF, but I think it's still usable. Let me know, maybe you have more experience than I do, if it could still work. Probably if I would calibrate the NanoVNA for VHF and UHF frequencies, I might get better results when I measure. But since my interest is mostly on HF, That is what I was mostly interested in, and I'm really happy with the results. So anyway, thanks so much for watching. I do hope this video will help you, and I'll see you in the next video. Until then, 73 from Yankee Oscar 6 Delta X-Ray Echo, and have an amazing rest of the week.